Okay, I want to show you a little kind of a handy tool for doing some mole calculations, and that we might be able to call this the mole map. Alright, so if you put moles in the middle here, and this is just designed to be kind of a map to organize your thinking when you're approaching mole problems. Let's say that I want to go convert between moles and mass. So if I want to go from moles to mass, then I'm going to be multiplying by the molar mass, which of course is mass per mole. And this will come from the periodic table. And if you want to go the other way around, if you're going from mass to moles, then you're going to be wanting to cancel mass and convert to moles. So you want moles in the numerator. If you want to go to a count, to a number of atoms or molecules from moles, then you're going to be multiplying by 6.022 times 10 to the 23rd per mole. And that is going to be atoms or molecules. That's Avogadro's number. And if you're going backwards from a number of things to moles, then you're just going to invert that conversion factor. And finally, if you are talking about a very specific case of the volume of a gas, so the volume of any gas at standard temperature and pressure, to go from moles to the volume of any gas at standard temperature and pressure, you're going to be multiplying by 22.4 liters per mole. And to go backwards, you'll just use the inverse of that. So you'll be multiplying mole over 22.4 liters. Okay, now just keep in mind that this last piece here is the volume of any gas. Is a very specific case. It has to be at 0 degrees C in 1 atmosphere, standard temperature and pressure, and it must be a substance in the gaseous state. But it doesn't matter which gas it is. It could be air, it could be CO2, methane, whatever. It doesn't matter. So this map can help you out. For example, let's say we have a problem, and this was on your Talk to the Mole worksheet, that said, what is the mass in grams of one molecule of water? So in this case, we're being asked about the grams. So we're being asked to go to this part of the diagram. And we're being given a count, 1 molecule of water. So we're starting here. That means we're going to have to go from count, we're going to have to convert to moles, and then from moles to mass. So here's what the process would look like. We have 1 molecule, H2O. Remember, factor label method, automatically those units go in the bottom of the next conversion factor. Now, what do I want on the top? Well, remember, I have to go from count to moles first and then to mass. So I want moles to be up here. It's going to be 1 mole. And how many molecules? Avogadro's number, 6.022 times 10 to the 23rd. So now I'm in the middle of the diagram, and I need to take this step over to mass. And for water, that's about 18.02 grams of H2O for every 1 mole. Again, where did the 18.02 come from? That is 2 times the mass of hydrogen plus the mass of oxygen. So that is the gram atomic mass, or the gram molecular mass of water. Now let me grab a calculator. And we'll run these numbers. We've got 1 divided by 6.022 times 10 to the 23rd times 18.02 gives me, we'll say 4 sig figs here, so because we have exactly 1 molecule. 2.992 times 10 to the negative 23rd grams. See how that works? And we can follow the same process whether we're dealing with a gas or any whichever way we're moving in this diagram. Just keep in mind that you don't always have to go across the diagram. For example, if your problem is only asking you to go between a number of things, number of atoms or molecules, and moles, then you only have a one-step conversion. There's no need to go all the way to mass with that. So hopefully that'll help you out a little bit, help clarify things, and if you want, you can even memorize that picture, the mole map, in your mind and use that to help you with your problem.